Hello, hello. It's me again. Thank you very much for taking the time to listen to this lecture series. My name is Professor Andrew Timming, and I am the author of this textbook, Applied Statistics, Business and Management Research. I sincerely hope you enjoy reading this book and listening to this lecture series. In the previous lecture, we looked at how to formulate research questions and at the differences between qualitative and quantitative research broadly conceived. We also looked at the process of quantification, whereby we take our ideas and then we convert them into numbers and subject them to various mathematical processes to identify patterns. In this lecture, we'll be focusing on variables and how they fit within the wider quantitative research process. Now, it's really important, essential really, that you understand this topic. If you can't properly identify different types of variables, you won't be able to use the statistical techniques taught later in this book because different statistical techniques can only be used with certain types of variables. Okay, shall we begin then? All right, let's do it. This is the book for those of you who'd like to read along as you go through this lecture series. I wrote it for the non-mathematician, so anyone, even you, yes, you, can read it. You're most welcome to buy the book, but you can also access it for free at most university libraries. Let's talk a bit about survey design. We're going to talk about it briefly because in the next lecture, we will spend a bit more time looking at some of the best practices and worst practices associated with survey design, but I just want to very briefly introduce you to this concept. So one of the most popular tools that social scientists like myself use in order to collect data and quantify our ideas is the survey, also referred to as a questionnaire. We need to get data from somewhere. And for social scientists, the data typically comes from people. Sometimes it comes from organizations as well, but organizations, of course, consist of people. So ultimately, the data comes from people. You, I'm sure, have had experience in filling out surveys. Lots of companies administer surveys to understand how their consumers feel about the organization. Maybe if you've been an employee in an organization, it's possible you filled out a survey designed by your employer to gauge how you're feeling about work or to gather information about the workplace or about the business. Now, there are two general ways that social scientists like myself gather data. Firstly, if you design and administer your own questionnaire, that generates what we call primary data. Primary data are data that you yourself have collected as a result of your efforts to design and administer the questionnaire. Now, that's not the only way to access data in the social sciences. Data collection, of course, is expensive, and many people don't have the means or the know-how to design and administer their questionnaire. So the second source of data is what we call secondary data. If someone else has designed and administered a questionnaire, then we call those data secondary data. And oftentimes when social scientists collect their own primary data, they are required, if they receive funding from the state, for example, to make those data available to other researchers. So when someone else has collected data through their own primary means, sometimes you can access those data sets, and those data sets are called secondary data. Now, within questionnaires, essentially what you have is a set of variables, and it is this topic that the lecture will now turn to. So now we arrive at the fundamental question, what is a variable? it's absolutely essential that you understand what a variable is, because variables are the key constructs that statisticians or data scientists use in their statistical analyses. So I define a variable here as any construct or idea that varies. A variable is something that varies. When I was an undergraduate, I never really liked that definition myself because it sounds a bit tautological in the sense that you're simply saying that a variable varies. But ultimately, that's what it is. A variable is something that varies either according to the individual or the organization or whatever your unit of analysis is. Now, each variable is defined by metric properties that vary or change. Metric properties meaning numerical properties. And the reason we have to use numerical properties attached to our variables is that the statistical software that we use in our statistical analyses doesn't recognize words or ideas, it only recognizes numbers. So what we do is we attach a number to those categories. Now, it's very important that you're able to distinguish a variable from a response category. I'll give you a few examples. Gender is a variable. It's something that varies. But male and female are not variables. They are response categories that are attached to the variable gender. Similarly, race is a variable, right? An individual can be black or white or Asian or whatever. Black, white, and Asian are not variables. They are response categories that are attached to the variable race. Equally, age. Age is a variable, right? An individual can be 26, an individual can be 72. 26 and 72 years old are not variables. They are response categories attached to the variable age. Now, it's important that you understand that all response categories must be numerical. Sometimes that's easy because they're self-evidently numerical, right? Age is a numerical variable by definition. But other variables aren't automatically metric. They aren't automatically numeric. And when that's the case, we simply have to add numbers to each category. This is called coding the variable. So I've given the example here with gender. You could code this as male equals 0 and female equals 1. It's actually quite arbitrary how you could do it. You could do it the reverse as well. You could say female equals 0 and male equals 1, or male equals 1 and female equals 2. Or you could even use something strange like female equals 32 and male equals 33, although I'm not sure why you would want to do that. Generally, when we assign numeric values to categories, we assign them as 0 and 1, and I will explain why we do this in future lectures. There are 3 different types of variables according to how they are measured. Some textbooks use 4 different types, but I use 3 because the third and the fourth type are really quite similar to one another, can be treated as though they were the same. So I've listed out the 3 types of variables here. And as I said at the beginning of this lecture, it is absolutely essential that you are able to look at a variable and quickly identify it as either nominal, ordinal, or scale. And the reason that you need to quickly be able to identify the variables nominal, ordinal, or scale is that when we progress in this book and we start to learn statistical tests, bivariate and multivariate statistical tests, you will find out that certain statistical tests can only be run with certain configurations of variables. And so if you're unable to identify the type of variables you're dealing with, you won't know which statistical test to use. So the 3 types of variables I have here are nominal, ordinal, and scale variables. Let's start at the top. Nominal variables are categorical variables, and they are non-hierarchical. Non-hierarchical means that you can't place one
on top of the other. In other words, one category isn't more or less than another category. The response categories are simply different from one another. And because they're simply different and non-hierarchical, they must always be coded. So as I gave the example in the previous slide, gender is a good example, right? We have male, female, you could even have more categories if you wanted to. Male and female are non-hierarchical categories. One's not higher, one's not lower, one's not more, one's not less. They're just simply different from one another. And as I said, because computer software does not recognize what these words mean, male and female, we have to code those words by attaching a number to each response category. Now, ordinal variables are also categorical, but they are hierarchical, meaning that as the number increases, the degree of that variable also increases. So these response categories attached to ordinal variables can be rank ordered from higher to lower, but they too, like nominal variables, also must be coded. A classic example of an ordinal variable is one where you ask someone to respond on, say, a scale of 1 to 5, where 1 equals strongly disagree, 2 equals disagree, 3 equals neither agree nor disagree, 4 equals agree, and 5 equals strongly agree. These are hierarchical, right? We know that strongly agree is more agreement than agree, and we certainly know that agree is more agreement than strongly disagree. But as I said, these words, strongly agree, don't mean anything to statistical software. So what we do is we attach numbers to each of those response categories, and we typically do that such that the more agreement, that is strongly agree, would be the higher number, 5, and the less agreement, that is to say strongly disagree, would be the lower number, 1. So these types of variables are called ordinal variables. Lastly, we have scale variables. These are continuous, hierarchical, and do not need to be coded because each response is meaningful in and of itself. I gave the example in the last slide of age. Age is a good example of a scale level variable, right? Age is naturally numeric. When someone says, my age is 18, you don't need to code that 18 by saying 18 equals 18 years old. You simply know that 18 corresponds to the year that the individual has been alive. So scale variables don't need to be coded because their response categories are already intuitive. Another example is income. If someone says my income is $50,000 or pounds or whatever a year, you don't need to say 50,000 equals $50,000. You know that that 50,000 is already 50,000, right? So it doesn't need to be coded in the same way that narrative categories need to be coded. And of course, they are hierarchical as well, scale variables. That is to say, a higher number equals more of something, and a lower number equals less of something. Don't worry if this isn't entirely clear based on this slide, because I have a few slides coming up that will hopefully clarify what each type of variable looks like. So these are just a few examples. There are many more, almost an infinite number more, but these are a few examples of typical nominal level variables, a couple of which we've already looked at. So as I said before, gender is a nominal variable, and we would typically code that as 0 equals male, 1 equals female. Or if you wanted to include more categories, as I know people tend to do these days, you could add further categories. It would still be a nominal variable. Race is a nominal variable. Now, there are different ways that we could measure race. On the slide here on the second point, race could be measured where 0 equals white and 1 equals non-white. That's one way to do it, as a binary variable like gender. But you could also measure race as a multi-categorical variable. So just there's, again, many different configurations of this, but the one that I've listed here on the slide is 0 equals white, 1 equals black, 2 equals East Asian, 3 equals South Asian, 4 equals mixed race, and 5 equals other race. Contract type might be a nominal variable that management scientists might use. So you could code this as 0 equals a continuous contract, a permanent contract, and 1 equals a fixed term contract. Favorite color is a nominal variable. Don't ask me why a management scientist would want to ask this question, because it's not entirely clear how your favorite color would be related to any particular outcome in management. But just for the purposes of an example, favorite color could be coded 0 equals red, 1 equals orange, 2 equals yellow, 3 equals green, 4 equals blue, 5 equals indigo, and 6 equals violet. I, for one, have a bit of a difficulty in distinguishing between indigo and violet, but I guess that's just me. Now, any question that has either a yes or a no, or an either or an or response is automatically a nominal variable. This is called a dummy variable, a nominal two-category variable. So any question that has yes, no, black, white, this or that response categories is by definition a nominal variable. Here's a few examples of ordinal variables. Remember that ordinal variables, like nominal variables, are categorical and they have to be coded. But nominal variables are non-hierarchical, whereas ordinal variables are hierarchical. Right? So the first one is probably the most widely measured variable in all of management science, and that's job satisfaction. How satisfied are you in your job? And you could code this as 1 equals very dissatisfied, 2 equals dissatisfied, 3 equals neither satisfied nor dissatisfied, 4 equals satisfied, 5 equals very satisfied. Now remember, this is just an example. You could equally code this as a scale of 1 to 7 if you wanted to, with slightly different response categories, giving you a bit more of a fine tune when it comes to your measurement of job satisfaction. Take a look at the second variable here. Students who graduate from Ivy League universities make better employees than students who graduate from non-Ivy League universities. Here we have 1 equals strongly disagree, 2 equals disagree, 3 equals neither agree nor disagree, 4 equals agree, and 5 equals strongly agree. How about this third question? How well did you perform in your job last year? 1 equals poorly, 2 equals slightly below average, 3 equals average, 4 equals slightly above average, and 5 equals very well. So all three of these variables you can see are ordinal variables. They're hierarchical, but they need to be coded in order for the computer software to understand what these response categories mean. Now it's important to make sure that you code ordinal variables intuitively. And when I say intuitively, what I mean is that higher numbers should imply more of what you're measuring and lower numbers less of what you're measuring. It gets quite confusing if, for example, 1 equals very satisfied and 5 equals very dissatisfied, because what that means is as you go up in numbers, you're not getting more satisfied, you're getting more dissatisfied. Now, here you can find some examples of scale level variables, right? So remember that scale level variables, like ordinal variables, are hierarchical, meaning that a higher number equals more of something and a lower number equals less of something. But unlike ordinal variables, they do not need to be coded, right? Because the numbers are intuitive in and of themselves. The numbers, the responses are meaningful in and of themselves. So you could ask in a questionnaire, how old are you? And then the individual could write, I'm 27, I'm 48, I'm 53, or whatever. How many days were you sick in the last year? This might be a important question for a management scientist, right? Someone might put the number 10. You don't need to code that number 10, because if someone responds 10, you know that that already means that they were sick 10 days in the last year. What is your IQ score, right? If someone reports an IQ of 105, you don't need to code what that 105 means. You know that that means an IQ that's just slightly above average. Other examples of questions that are typically measured via scale is how much money did you make last year? In other words, what was your income? If you were asking a manager a question, you could ask how many employees work in this organization? How many hours do you spend in front of a computer per week? Unfortunately, I would have to respond rather high on that question. How many reports did you file in the last year? Might be a question that a management scientist asks. So the important point to take away here is there's no need to code responses to these questions because the response categories are meaningful in and of themselves. Finally, it's important that you're able to distinguish between independent and dependent variables. Now, these have nothing to do with level of measurement. They have something to do with which variable precedes the other. All right, so let me explain what I mean. An independent variable, also commonly referred to as a predictor variable or an input variable, independent variable is assumed to have some kind of effect on the dependent variable, right? So it is causing some kind of change or process. A dependent variable, on the other hand, also commonly referred to as an outcome variable, is assumed to be affected or to be somehow influenced by the independent variable. So in this case, the independent variable always precedes the dependent variable. Now you might be tempted to say that the independent variable causes the dependent variable, but you have to avoid this kind of language. This kind of language implies causality or causation, and the problem with social science research is that it's virtually impossible, it's possible but virtually impossible, to establish causation. And the reason is that there is an infinite number of causes associated with a particular effect, and it's hard to isolate a particular cause on a particular effect. Natural scientists don't have this problem because they design experiments to make sure that cause and effect are very clear cut. But in the social sciences, we do have a causality problem. So although implied in independent and dependent variables is some kind of effect or influence or impact, you can never use the terminology that the independent variable causes the effect in the dependent variable. Well, thank you very much for listening to this lecture. I look forward to seeing you at the next lecture. See you on the flip side.